This is Algebra 1, Lesson 64, and this lesson we're going to cover domain and additive property of inequality. Alright, so the domain is the set of possible replacement values for the variables in a particular equation or inequality. That's called the domain for the equation or inequality. So domain just tells us what types of numbers we can use in an equation. So sometimes some sorts of numbers are not going to be permissible as the answer to an equation. So for example, let's say that we had an equation where we were selling eggs for 50 cents each. So we could say, let's see, let me get my pen here. So if each egg costs 50 cents, X would be the number of eggs times 50 cents equals our cost. Okay, so let's say that we had 3 eggs. 3 times 50 cents would equal $1.50. But we couldn't have negative 3 eggs. That wouldn't make any sense. So the domain for that would be positive numbers. Alright, so this is what your problems are going to look like. This one says graph X is greater than 2, and we only want real numbers. Well, that one's pretty easy. X is everything that's more than 2. It's not equal to 2, so we're going to use an open circle, and we're going to go that way. With real numbers. Alright. Let's try another one. This one says graph X is not greater than or equal to 3. And for this one, we want to use integers. Integers are only whole numbers, negatives and positives. So X is everything that's not greater than or equal to 3. So it can't be equal to 3, but it can be equal to 2. It can be equal to 1, and 0, negative 1, negative 2, negative 3. See how I'm just making dots? That's to show that it's only the whole numbers. It can't be 1.4 or 1.5 like right there. Doesn't count because it's only the whole numbers. So when you see integers, you're going to use dots because that represents whole numbers only. Graph X is greater than or equal to negative 1, and for this one, real numbers, so that's going to be all the numbers and everything in between. So when you see reals, you can make a line. So X is greater than or equal to, so that means we fill in our dot on negative 1, and that's going to be everything greater than negative 1. And the filled in dot means equal to negative 1. So that's greater than or equal to negative 1. Real numbers, so we're just going to make a line. X is less than negative 1, and this has to be positive integers. No, X is, let's see. For this one, everything that's less than negative 1 would be down here, right? But this is positive integers. There are no positive integers that are less than negative 1. So the answer to this one would be the null set or the empty set. So the null set, we draw a circle with a line through it. Means there are no numbers in that. Or you could just draw a set with nothing in it. Right? So that one, basically there are no numbers that fill that equation. Alright. Graph X is greater than or equal to negative 5, and we need positive integers. This is going to be all the positive numbers that are greater than or equal to negative 5. So we can't do negative 5, we can't do negative 4, negative 3, negative 2, because those are all negative numbers. We only need positive numbers. So that's going to start right here at 1. And these are dots because it's integers. So that's how you graph that one. All right, additive property of equality. We've already learned this. It says that A plus B is the same thing as B plus C, and C plus A is equal to C plus B. All right, so that means like if we had 3 plus, actually let me do X plus 3 equals 5. We could do the opposite of that, which is minus 3, and we're going to get X equals 2. So the same thing applies when we use the additive property of inequality. If A is greater than B, then A plus C would be greater than B plus C. Or C plus A would be greater than C plus B. So that means if we had X is greater than, X plus 3 is greater than 5, means we could do minus 3, and we would get X is greater than 5 minus 3 is 2. All right, so it works just the same way as when we work an equation. All right, graph X plus 2 is less than 0. Okay, so on these, you just have to work it like an equation. X plus 2 is less than 0. We're going to say minus 2, minus 2. Those cancel. X is less than negative 2. All right, so that's going to be real numbers. That means we can make a line. It's less than negative 2, so we use an open circle. And we go to the left. Everything that is less than negative 2. Okay, let's try another one. X minus 3 is greater than or equal to negative 5. So we're going to rewrite that. X minus 3 is greater than or equal to negative 5. So now we're going to do plus 3, plus 3. Those cancel. X is greater than or equal to negative 5 plus 3 would be negative 2. So on this one, we can only use integers. So that means we have to do dots. So it could be negative 2 because it's greater than or equal to. It has to be everything that's greater than or equal to negative 2. So we're going to use dots for each one of these numbers that are more than negative 2. All right, go ahead and work the practice problems, and then I'll work them for you. Okay, so hopefully you pause the video and work those practice problems. First is A, and A says graph X is less than or not less than or equal to negative 2, and we have to use positive integers. So it's everything that's more than negative 2. It's not equal to negative 2, and it has to be positive integers. So that's going to be everything that's more than negative 2, but we can't use negative 1. We could use, can't use 0. That's not positive. So it would be 1, 2, 3, 4, 5, and we have to use dots, and it can only be the positive numbers that are in the dots. Okay, next one. Graph X is not less than or equal to 4, and this could be any, this is real numbers. All right, so on this one, X is less than or equal to 4, so it could be equal to 4. Oh, no. Not less than or equal to 4, so that means it's everything above 4, but it's not 4, so we're going to do an open circle and a line. All right, another practice one. X minus 5 is not less than 0. So I'm going to rewrite this. X minus 5 is not less than 0. Now I'm going to do plus 5. X is not less than 5. So that means it has to be everything that's more than 5, and we're going to use integers, so that's going to be dots. So that'll be 5, 6, and if my number line went on, I could mark it at 7. All right, last one. X plus 2 is less than 5. So x plus 2 is less than 5. And this is going to be integers, so we're going to be using dots. We're going to subtract 2 from both sides, and we get x is less than 3. So this is going to be everything that's less than 3. It's not equal to 3. So we're going to start at 2, 2, 1, 0, -1, -2. All right, that's it for lesson 64.